So sometimes it's very helpful to compare two different sets of data, right? Just basically side by side, okay? And that's what we're gonna do today. And when you are comparing data like that side by side, a box plot is very, very useful to do that, more so than like a histogram. So at the bottom of this page, you have instructions on how to create two box plots side by side. We're actually going to do that for this. So what I want you all to do right now, please go ahead and take out your calculators and go to, press the on button and open up a new window. Add a spreadsheet. So what you're gonna do you see how you have two lists here? You're gonna put the 19. So let's just read what this is. This is the number of home runs hit in Major League Baseball in 1927 and 2007 by the top 20 home run hitters. So basically, the best home run hitter in 1927 hit these home runs throughout his games. And then the best home run hitter in 2007 hit these. Or the best home run hitters hit these. So you're going to put this in the first column and this in the second column. Let's go. Okay. So, yeah.
Is this for Alexis video?
Yeah.
Hi, Alexis.
Okay.
There's 20 of them.
1, 2, 3, 4, 5. 1, 2, 3, 4. Correct. Okay, so let's go ahead and do this.
Over 5 mistakes.
What?
Over under 5 mistakes.
Okay. Shh, guys.
Over under 5 mistakes.
Okay, so here we go. We have our two lists. You're gonna label both of them. Okay. You see how here it says 1.1 and I don't have any other tabs open? That means like this is a fresh list. So label it whatever you want. However, if this is your like 1.19 and you know you have other lists and you have another list somewhere that you've labeled A, pick an original name or just shut everything down and start over, right? So here, and unfortunately it doesn't let you type in the numbers. So you know what I'm going to do? I'm going to do old and new here. Just because.
I wrote it B and C.
You can do whatever you want. You just need a label for it. Okay, so now we're going to follow along with what we have here, right? We did steps 1 to 3, labeling all columns. Step 4 is control new document, just like before, and we're going to add data and statistics, just like before. Now, this is the most important thing. Never go on the y-axis. Always go on the x-axis. Click to add variable. I'm going to do the first list first, right? See, when you do this, it gives you the option. So I'm going to do my list A first. This is the 1927 one. And then we're going to go to menu, plot type, box plot. And we're going to do this. If your box plot has these two dots here, we're not going to do that. What you want to do is menu, plot properties, extend plot whiskers, and it gives you a cute little graph like this. Okay, so take a look. Does your axis on the x-axis, does it go from 28 to 56? What does it go from?
5 to 60.
Mine's like 14 to...
I think it's just
Okay, here we go. Let's go. Okay, here's what you need to do. Menu, window zoom, window settings. And you can actually dictate what you want this to be, right? But now remember, we're eventually going to add these numbers to it too. So you want the smallest one in both lists. What's the smallest one in both lists? It looks like it's a 10. And then the highest one in both lists, I think it's a 60. So you want it to go from like 10 to 60, which it looks like this does not.
Okay, mine's better now.
Okay. So let's go from like 10 to 60. Okay. This is making me feel like I misnumbered some list, but
That's okay.
oh,
Everyone makes mistakes.
wait a minute, wait a minute. This is the new one. Oh no, I meant to have this as the old one. Okay, it's okay. So what you want to do now, we want to add the second list to this. Okay, so go here. Now we're on step number 8. Go to where, on the x-axis where you click for the variable. So click there again. Now it gives you the options again. Select the other one. And you should have both. Why doesn't it?
No.
Oh, no. Sorry. Oh my gosh, I'm so sorry. Okay, I want to make this my 1927 one, which is the old one. Okay, here's what I want you to do. I'm so sorry. Go to step 8, menu, plot properties, add X variable. And
Okay.
here, now I want the new one. There you go. Isn't that cute?
Wait, I'm not there yet.
Okay.
Whoa.
Okay. All right, awesome. So now you have both of them. All right, so now what we're going to do is we're basically going to transfer these onto our paper. And so remember how we said we were going from 10 to 60? So when you do your axis, you want to make sure all of the values are represented. So we're going to go from 10, 20, 30. Oh, you know what? Let's take a look at the numbers here. Look at the numbers. So I've got, 10, 14, 16.5, and so on. I think it's too broad to go up by tens. We need a little bit more detail, so we're going to go up by 5. So this is 10, 20 is here, 30, 40, 50, and then 60. Okay, so it's also important for you to give the 5-number summary. So here we have 1927. I'm going to do a little table to make it more efficient. 2007. And here I have Q1. I'm sorry, minimum first. Q1, Q2, Q3, maximum. So go ahead and write down both of those values for these. For 1927, we're at 10, 14, 16.5, 23, and 60. And then for 2007, we're at 30, 32, 34, 38, and 54. Okay, so now we're going to put these here. We have to label this, and this is going to be basically number of home runs. Okay, so the first one, we're at 10, 14, 16.5, 23. And then we're at 60 all the way here. All right. Next, go a little bit above. It doesn't really matter how high up you go. We're at 30 and then 32 and 34. And then we're at, oh no, sorry, 30, 38, and we're at 54. And now we need to label these. So I label this 1927, and I label this 2007, just so we're clear and we know. You can even just put it here. Okay, Or you can do different colors and make a legend. It's up to you. Okay. Like, yeah, like you can make it like different colors and then just say like this color represents 1927. Okay. Yeah, a key. So here it says construct the box plots and then use this display to compare the distributions. So what do you think? Just by looking at this, do you see how like powerful this can be in comparing this data? Just by looking at this, what's the first thing that hits your eye? Right, but like what's like the first difference?
We're not even.
Right. What else? What's the first difference between like the years 1927 and 2007? So these are all the number of home runs, right? When?
In 1927.
Right. So look at this. In 2007, all of the home runs are pretty much concentrated here. So on average, you know, people were batting a greater number of home runs here, right? Whereas earlier they were batting an average of less home runs. Okay. So one thing you can say is in 2007, huh?
You have to say something?
Yeah, because it says to use it to compare the distributions. In 2007, players hit more home runs. However, look at that. The maximum, the highest was still in 1927 though, right? So, however, max home runs was in 1927. And it's not up to us to say, you know, why, you know, there were, you know, more home runs later than before. That's not what the data is saying. The data is just saying what it is. Okay? All right. So from that, let's move on to percentiles. Whenever you get your test scores back, right? PSAT, SAT, or whatever, it always says, okay, you scored in like the 87th percentile. What does that mean if it tells you scored in the 87th percentile?
You were within 87% of people to get them.
You were able to what?
And 87% of people got this, like the same.
Got 87% of the people your age who took that specific test, 87% of those people scored at your level or below. In other words, you are in the top 13%. If your percentile is 87, if you do 100 minus 87, 13, you're in the top 13%. Okay? All right. So we're actually going to construct a percentile graph right now. This is a frequency distribution of the heights of girls in Mr. Lee's pre-calculus classes. So there we go. 11 students have heights 59 to 61 inches, right? 60 is, what 5 feet, right? 60 inches. And then 72 inches is 6 feet, right? So just, and then 12 people have heights 68 to 70 and so on, okay? Nobody has any, is shorter than 59 inches, and nobody is taller than 73 inches. Okay, so this is the frequency distribution. We're gonna start with this. We're gonna calculate the percentage, which you get that from the relative frequency, right? We're gonna take the relative frequency and convert it into a percentage. So total, when you add all these up, you have 60 total. So what we're going to do is 11 out of 60. That's 18%. 15 out of 60, that's a quarter, 25%. 15 out of 60 again, 25%. 12 out of 60, that's 1/5. 20%, and then 7 out of 60 is 12%. How much should all this add up to? 100%. Facts. Now, percentile is this. Percentile is the cumulative percentages of the group. So in the first group only, yes, it's 18% of the students. In the first and second groups, it's 18 plus 25. How many? 43%. Okay? And then if you now add to this the next column,
9.
you get 68%. And then 20 more, you get 88%. 12 more, you should get 100%. Because by the time you come here, you included all of the groups, and that's 100% of your data. Okay, now we're going to graph this. What we're going to do is you're going to graph this on the y-axis. And then here for the classes, you're going to graph these values, the second values, the upper bounds, on the x-axis. All right? So here we're going to have, on the y-axis is going to be the percentiles. And these usually go up by tens. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay? Over here, these are the heights, right? In inches. Okay, so now, the first number I have here is 61, all right? Or 59. So take a look at how we're going to do this, guys. We are going to do the little squiggly. Okay, now, yes, the first thing we're going to plot is 61. And notice these, because they're equal classes, they're going to go up by equal numbers, so we don't have to deal with that. But what's the lower? Okay, so here, do you see how you've got the squiggly? Skip one, and here you have 61, 64, 60 what? 7, 70, 73. Okay.
It's so condensed though.
Yeah, if you want to skip one, you can skip, like there was room to skip maybe like a few. It's okay, it doesn't matter though, Nissan. You can even like write it vertically. Now, the bottom class here is 59, right? But since we're going down by threes, put in the bottom one as well. What would it be? 58 if you go down by 3. Yeah? Right? Because that would have been like the end of the previous class. Okay, so we kind of artificially added that. Okay, so now, how many people in this class are at a 58 height? 58 inch height? 0. So that, you're going to put 0 there. Okay? All right, 61. How many are at 61? 18%. So here, put a dot. How many are at 64? 43. How many are at 67? 68. Then 88. And then finally, you should end by 100. And now you have to connect these points. It's not going to be a smooth curve. They're going to be jagged edges, and that's okay. All right? Because like one doesn't depend on another. So there is not going to be a continuous curve. So we're going to do this, 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 this. Okay, literally like connect the dots like you used to do when you were little. Okay. Whew. Now it says estimate the percentile rank a girl with a height of 68 inches would have in this distribution and interpret the meaning. So 68 inches, if you look here, it's right after the 67. So it's like 1/3 of the way in from the 67. So here. Right there, right? Well, what percent is that if you follow here? How many is that? It's like about 78%, right? All right. Somehow my computer's frozen, but it'll be about 78th percentile. Okay? So those are percentiles. How does that sound?
Good.
Yeah. Okay. I can't stop this video. Okay. All right, so let me get you all started on homework. Let's see.